Stack and queue. The objectives for our course are understanding the operating principles of the stack structure, learning to use the program to conduct stack structure and use it to solve problems, and understanding the operating principles of the queue structure, learning to use the program to conduct the queue structure and use it to solve problems. The concept of stack and queue is actually commonly seen in everyday life. Stack resembles plate stacked high with the characteristics of last in, first out. Queue resembles a group of people lining up for purchase with the characteristic of first in, first out. Let us begin with stack. Stack. There are two main basic actions in the stack structure. The first is push, which is adding data to the top. The second is pop, which is removing data from the top. This means that all data processing will be conducted at the top. Therefore, when we use push to add the data, we will start putting the data into the container from A. After placing A, B will be the next, then C, D, to E. When we need to remove data, use pop to remove the data from the top. Therefore, it will be inverted and E will be removed first. We can observe that A, which was pushed the earliest, is removed last. However, E on the very top, which was pushed into the stack last, will be removed first as it is at the top of the data during the removal. This is a characteristic of the last in, first out for stack. What matters or scenarios would require the use of the stack structure in life? Amongst the plates stacked up high, we always take the plate on the top to get our meals, and the plate on the very bottom will only be removed later. When using the fitness equipment at a gym, different bar plates will often be used to increase weight for the loading. The process of putting up or removing barbell plates is also a stack application. After clothes are hung up and dried, pieces of clothing will be folded and stacked for storage. Clothes that are folded later are normally placed on the top of the pile of clothes. Applications of stack. Try out this application based on the stack characteristic of LIFO. Use the data structure of stack and place the four elements of 1, 3, 5, and 7 in sequence. After removing two of the elements, further place the three elements of 10, 15, and 16, and then remove one element, and then place 20 in the end. What is the order of the elements from top to bottom? Place 1, 3, 5, 7. Remove 7, and remove 5. Add 10, 15, 16 on top of the existing 13, then remove 16. Place 20. Did you get it right? Moreover, the order of a sequence can be altered by using the stack structure with a series of push and pop commands. For instance, the original stacking order was 1, 2, 3, whereas after going through the process of push, pop, push, push, pop, pop, the order of removing from the stack became 1, 3, 2. How is this accomplished? Let's do it step by step. Push 1. Pop 1, record 1 removed from the stack. Push 2, push 3, pop 3, record 3 removed from the stack. Pop 2, record 2 removed from the stack. This way, the order of removal became 1, 3, 2 instead of 1, 2, 3. Now let us think. If the original sequence was 1, 2, 3, 4, 5, 6, the order going into the stack would be 1, 2, 3, 4, 5, 6. After the operation of 12 commands, 6 push and 6 pop, which sequence is impossible when following the order of removing from the stack? A. 215436, B. 324156, C. 154623, D. 326541. The first number for option A is 2. We will need to place 1 first, and then place 2, and then remove 2 before removing 1. Therefore, the first few steps would be push 1, push 2, pop 2, pop 1. Then comes the part for 3 to 6. We want 5 to be the third one removed. However, we need to place 3, 4, 5 before removing 5. push 3, push 4, push 5, pop 5, pop 4, pop 3. The last will be 6, push 6, pop 6. Therefore, we know that option A can be accomplished. Think about what should be done for option B. The first number is 3, then the numbers before 3 must be pushed in first. Push 1, push 2, push 3, pop 3, pop 2, leaving 1 inside, but our next demand is 4, therefore, push 4, pop 4, pop 1, and then push 5, push 6, pop 6, pop 5. The next option will be D. Push 1, 2, 3, pop 3, pop 2, push 4, 5, 6, pop 6, pop 5, pop 4, pop 1. This option can also be accomplished. As for option C, we can compare step by step, and we will then discover the first few steps can all be accomplished until the structure is left with 2 and 3. Due to the characteristics of first in, last out, using pop will remove 3 first and then remove 2. Here we are going to use a list for conducting the stack structure. Thus, let us review what has been learned. The nodes in a list include 2 main parts, data and link. Link stores the address for the next node, while the link for the next node stores the address for the node after the next. Also, the first node in the link is known as a head, where there is no connecting node ahead of it, while the last node is also without a connecting node behind it. How to create a list? First of all, set a structure, define a type with the name as node, which contains 2 different types of variable forms. Integer variable, data for storing numerical data. Pointer variable, the pointer variable with node, as the type points to the next variable with node as the type. Now we are going to implement the push action. The key is that data will be added on top of the original data when stacking new data. Step 1. The pointer variable of the newly added data will point to the original head. Step 2. Treat the newly added data as the new head. Let us get to the program code part. The first line of the program declares a user-defined function push with the objective of adding the new data on the top of the list. Therefore, 2 parameters will be passed in. The first parameter represents the position of the top of the list. The second parameter is the newly added numerical data. Then, declare the variable new node, representing the node newly added to the top. Assign the value passed into the function to the data of the new node. Assign the position of the original head to the next of the new node. Set the new node as the new head. Now we are going to implement the pop action. The key is the data originally at the top will be deleted directly when stacking pop data. Step 1. Set the next node pointed by the pointer variable of head next as the new head. Step 2. Delete the original head directly. Let us get to the program code part. Declare a user-defined function pop. The objective is to delete the data at the top of the list. Therefore, a parameter will be passed in, representing the position at the top of the list. Step 1. If the list passed is a null value, it means that the current list contains no data, and therefore no node can be popped, hence a null value, null, is returned. Step 2. Declare a variable in the form of node and the name of temp node, and assign it as the head currently passed into the function, representing the node at the top of the list. Step 3. Set head as the position of the next node originally pointed to. Step 4. Delete temp node, as the head has been set to relocate to the next node in the list. Therefore, deleting the node originally at the head of the list means removing the node at the top. Finally, return the changed result to the main program originally called. Now we are going to output the data in the stack. First of all, declare a user-defined function display list. Pass it to the position at the top of the list. Then, when the node passed in by the function is not an empty node, output its data on the screen and set that node as the position of the next node pointed by the pointer variable. Continue to output the value of the node. Until an empty node is encountered, the while loop is shown and null is displayed. Let us explore the part regarding the stack main program. What does this program code mean? Declare a variable in the form of node in the main program and name it to head to represent the node at the top of the list. Call the push function. Push in the node with a numerical value of 20 at the top of the list. Call the push function. Push in the node with a numerical value of 30 at the top of the list. Call the pop function. Remove the data node at the top of the list. Call the display list function. Print out the data content of the list from the top of the end. At last, would everyone please write the program code according to the question? Use the data stack structure, place the 4 elements of 1, 3, 5, 7 in order. Take out 2 of the elements, and then place the 3 elements of 10, 15, 16. And then take out 1 element. Then finally, place 20. What is the order of the elements from the top to the bottom? Please write down the program code to implement this example. Queue. There are 2 main basic actions in the queue structure. The first is Enqueue, adding data at the end. The second is dequeue, deleting data at the front. One major characteristic of the queue structure is FIFO, first in, first out. Now, the data A queue, what we actually enqueue, has a front and an end. Therefore, when we continue to enqueue data B, the end of the queue becomes data B. Let us continue to add data C, D, E at the end. Please observe the changes at the end of the queue. Then for the dequeue part, which deletes data from the front end, dequeue A, then the front end of the queue will become B. Continue to dequeue B, C, D, E. According to the aforementioned example, it can be seen that A is the first to enter the queue, but it is also the first to be removed during the removing process, while E, the last data added to the queue, is the last one to be added to the queue. Hence, it is also the last one to be removed during the removal. After understanding the queue structure, think about what scenarios in life would require the use of the queue structure. When we encounter scenarios that require lining up in life, the queue structure will be used. For instance, when lining up to buy face masks at a store, people at the front of the queue will have the priority to purchase, while people who arrive late can only join the end of the queue to line up. When several computers share a network printer, files that are transmitted first will be printed first, whereas a file that is transmitted later will only be printed once all of the files before it have been handled. This is also a concept of the queue structure. Applications of queue. Based on the characteristics of queue, try out this application. Use the queue data structure. Add the 4 elements of 1, 3, 5, 7 in order. Remove 2 of the elements, and then add 3 elements of 10, 15, 16. Then remove 1 element, and finally add 20. What is the order of the elements in this queue from the front to the end? In queue, 1, 3, 5, 7. The end of the queue will move along. Dequeue 2 elements. They will be deleted from the front. Enqueue 10, 15, 16. Dequeue the first element. Finally, enqueue 20. It will be 7, 10, 15, 16, 20. Use the linked list to implement the queue structure. The nodes in a linked list contain data and link. Link stores the position for the next node, while the next node stores the position for the node after the next. Therefore, the link of the previous node stores the position for the current node. The frontmost node of the link is the head. There is no more connecting node before it. The node in the end has no more connecting nodes behind it either. We can implement the data structure of the linked list via struct. Define a type named node, containing the integer variable data for storing numerical data, and a pointer variable with node as the type, pointing to the next variable also with node as the type. Now, let's implement the Enqueue action. The key is that Enqueue will add the data to the end of the original data. Step 1. The end of the original list will point to the newly added data. Step 2. Connect the newly added data to the end of the queue and set its pointer variable to null. Let us get to the program code part. First of all, declare a user-defined function Enqueue. The objective is to add the newly added data to the end of the list. Therefore, 2 parameters will be passed in. The first parameter represents the position at the front of the list. The second parameter is the newly added numerical data. Let us use the program code with a linked list to see what happens. Declare a new node, representing the node added to the end of the list. Declare current. Set it as the head, representing the node at the front of the list. The data of new node is the data passed into the function. Because the position of new node will be at the end of the list, hence set the position of new node to null. If head is an empty node, null, it means that there is no node in the list. Then, the node added to the list will be the head. Use the while loop to move current to the end of the list. The principle here is that the current node has previously been set as the head already. Therefore, use the while loop to check whether the pointer variable of the current is null. If not, it means that there is still a node pointing to the next link. Therefore, set the current node as the node it points to until the pointer variable stored in that node becomes null, meaning that it is the end node of the list. Point its current pointer variable to new node, and add new node to the end of the list. This completes the action of enqueuing new data into the list. Finally, implement the dequeue action. The concept of dequeue is deleting the data originally at the front directly, and the next data is the new front. First of all, we will set the node, which the pointer variable next of head points to as the new head. Then delete the original head directly. This is how dequeue is implemented. Let us introduce the program code. First of all, declare a user-defined function dequeue. The objective is to delete the data at the front of the list. Therefore, a parameter will be passed in representing the position of the front of the list. How to implement dequeue? Step 1. If the list passed in is null, it means that currently there is no data in the list. Therefore, no node can be removed, and hence an empty value null will be returned. Step 2. Declare a variable in the form as node and the name as temp node, and assign it as the current head passed into the function, representing the node at the front of the list. Step 3. Set head as position of the next node originally pointed to. Step 4. Delete temp node. As head has already been set to move to the next node in the list, therefore, delete the node originally at the beginning of the list, meaning removing the node at the front. Finally, return the change result to the main program originally called. How to output the data in the queue? First of all, declare a user-defined function displayList. The objective is to display the contents of list one by one, after passing in the position of the node in front of the list. When the node passed in by the function is not null, output its data on the screen, and set that node as the position for the next node pointed by the pointer variable. Continue to output the value of the node. Finally, output null representing the end of the queue. Finally, let us implement the main program for the queue. Declare a variable in the form as node in the main program, named head, to represent the node at the front of the list. Call the Enqueue function Add the node with the data 20 to the end of the list. Call the Enqueue function. Add the node with the data 30 to the end of the list. Call the dqueue function. Delete the data node at the front of the list. Call the displaylist function. Print out the data content from the front to the end of the list. Finally, would everyone please write the program code according to the question? Use the Q data structure. Add the 4 elements of 1, 3, 5, 7 in order. Remove 2 of the elements, and then add 3 elements of 10, 15, 16. Then remove 1 element, and finally add 20. What is the order of the elements in this queue from the front to the end? Please write the program code to implement this example. Answers to the questions of stack and queue. Stack implementations. Let us look at the stack implementations amongst the stack queue. We wish to implement stack and perform 3 functions: push, pop, and the function of outputting stack. How should we do it? First of all, we will establish the C++ format. Followed by our main program code region. Remember to return 0. Then we would like to implement stack. It will be the same as we did when we created the list earlier. We can use a structure as a node. Create variables inside according to what we want to put in. We will create data here and our link called next. Also, be especially careful that there must be a semicolon at the end of the curly bracket. Next, we want to conduct 3 functions, which are push, pop, and output respectively. Therefore, let us create the function. I would put a node for push. Then put the data we want to insert. As for pop, it is very similar to push. But since we do not need to add additional data, as there is nothing to add, therefore, we only need to know where the head of the stack is. The next would be display. We can use display list. Similarly, we only need to know where the top of the stack is. Then we can know where to begin the display. Next, let us think about how to implement this. Let us start with the simpler display. Display list. We will call the thing inside a node, then. Now we start with the output from the top of the entire stack. So we can use a while loop. Before our node becomes empty, before it becomes null, we can display its data. See out node data. use the small arrow from the list before to tell the user to tell everyone which will be our next data. After displaying the data, then we can move this node one block down to its next. Next. It will keep moving this way until this node becomes null, and it will exit our while loop. Meanwhile, when the node actually becomes null, we will display a reminder. Display a null reminder. This way, we can be certain that we have already output to the end. This part is basically the same as the linked list before. You can review it. Then, let us write the push part. First, we will create the parameters. We will start from the top, then run our data. Add the data to be added. Therefore, we will create a new node, which is the one we would like to push. Create a new node. Meanwhile, the data in the new node will be the node data in our parameters. For our stack, it is added from the top, meaning that the node newly added will be located at the top. Therefore, its next node will be the original head, the original top. Just like originally, it was 4, 3, 2, 1. 4 is at the top. I will now add a new node 5. Then 5 will be the new node. The node below it will be the 4, which was originally the head, originally the top. This is why the next of our new node is the head. After it is done, we can then process the head again. Make it the new node. This way, the program will know who is at the top of this stack. The head will then be returned. Then it is completed. Is it easier than list? Finally, pop. Popping things out of the stack. Therefore, we only need to know where the top of the stack is. As for the parameters, we must know where its top is. Then let it pop the thing at the top. First, let's check whether there are things that can be popped. If our top is empty, then we have nothing to pop. Therefore, we will then return null. If it is not empty, we have something to pop. Then, we'll first create a temp node. Make it the head, as we need to move the head first. We need to pop the top, and the head will change. Just like our 5, 4, 3, 2, 1 before. the top is 5. We want to pop the top, and then 5 will disappear. Now, the new head will be 4. Therefore, we will make the head the one following the head. However, if you did not use a temp node to store the 5 before, we will not be able to know where the 5 is. Therefore, use a temp node to store 5. Make 4 the head. Then we will delete temp node. This way, we will be able to delete 5 successfully, which was at the top. And the head will become the new top, which is 4. The top will then be returned, and it will be completed. Now, we have implemented all 3 functions. Those who have not yet finished can stop for a while and check this out. Okay, after completing this function, we will return to the region for the main program code. You can test it here as you like. First of all, we will create a head. The head will be empty at first. Then we can conduct some actions such as pushing or popping, and then finally displaying, etc. Here we will demonstrate push. Inside, we will include who the head is now and the data you want to push. Let us push 2. You can also try pushing more things. Next, let's pop. Then we can display. A little reminder here. You can either use final linking list or write stack directly. Or write in Chinese directly what the stack is now, and then display it. Let's try executing it. You can see that in the end 20 is linked to null. Since we pushed 20 and then pushed 30 and performed one pop, if you feel it is not obvious enough, we can perform output to check every time. It is all linked together when output, which is kind of annoying. Therefore, when you perform null here, you can also perform line break. This way, it will look clearer. Therefore, we push 20 the first time, push 30 the second time, and finally, we popped 30. Only 20 will be left inside. This is the code for our stack. Those who have not completed it can stop here and write it. Application of stack structure. Let us look at the stack practice among stack queue. Use the data structure of stack. Add the 4 elements of 1, 3, 5, 7 in order. Remove 2 of the elements. Then add the 3 elements of 10, 15, 16. Remove 1 element. And finally, add 20. What is the order of the elements from the top to the bottom? Please write the program to implement this example. Here, other than the main program code region, everything else is exactly the same as the stack implementation conducted in the lesson. Therefore, everyone can refer to the stack implementation from the lesson. Here, I will quickly type in the program code from the stack implementation. If there's anything you do not understand, you can always go back to review the video before. While I'm typing, you can all type as well. We will first create the node. Whatever data you need to put in will be all right. Then create its link. Remember the semicolon at the end. Then the push function, the pop function, and the display output function must all be processed. Next, write all three functions. For anything you do not understand, remember to go back to the video before. This part is to proceed with outputting the data. Give a reminder at the end when it is empty. This is the display part. Next, implement push. Create the parameters. We need to know the position of the top and which data we want to add. Remember, once you have something you do not understand and would like to see more explanations, go back to the video from the previous lesson. There will be more detailed explanations. Here, I hope you can practice more on your own. See if you can actually implement it after listening to the lesson. Finally, it's our pop. Similarly, we need to know who the head is. That's it. Check whether the head is empty. Because it is empty, we will not have any data to pop. If not, let us carry out the data pop. If you forget why temp node must be used, you can always go back to review it. This way, our 3 functions of push, pop, and display are completed. Let us take a look at what this problem requires. It requires us to put in order the 4 elements of 1, 3, 5, 7, then carry out pop. And then push and pop. Finally, see what it's like from top to bottom. We must carry out push. We can copy this section. We need to push a total of 4, 3, 1, 8 times. One, 2, 3, 4, 5, 6, 7, 8, and then pop. As for push, after pushing 1, 3, 5, 7, pop must be carried out. We will also copy the pop part. After making 2 pops, continue with push. Push 10, 15, 16. Then pop 1. Then finally push 20. This is our main program code region. After completing the actions, we can display what our stack will look like in the end. Let me try executing it. Here, we forgot to create the head. It is telling us that it doesn't know who the head is. Therefore, we must remember to create a node here in the main program code. Then name it head. The head will be null at first. It represents the top of our stack. Then it is asking which row it is. Row 33. We have a typo for the part row 33. Here we will have a null. But we typed in node originally. But for node, it should have a bracket or other condition because it is a structure. We have one typo. Now we can process it normally. Let's see, it is 20, 15, 10, 3, 1. We can check it manually. To see whether this result is correct or not, we put in 1, 3, 5, 7 in order. Things we put in will be at the top. Then take out 2. Therefore, 5 and 7 are removed. Then put in 10, 15, 16. Then take out 1. And then finally put in 20. So we have 20, 15, 10, 3, 1. This means that the program code we wrote is correct. Is that okay? Everyone can implement this here. Remember, you can refer to the practices in the lessons before. Then solve this question. Queue implementation. Let us look at the queue implementation amongst the stack queue. Now we are going to implement a queue with 3 functions: Enqueue, dequeue, and output our queue. Also, let us establish the C++ format first. Include IOStream using namespace stand and our main program code region. Return 0. Then, since we are going to implement queue, we will use the linked list method as well. Therefore, create the node first. Put whatever you want in the node. We will put data here and its next node. The link connecting to the next node is represented using next. Remember to add a semicolon at the end of the curly bracket. Then we will create 3 functions, which include respectively Enqueue, similarly, it needs to know our head and the node to add. Then dequeue. Here, we only need to know who the head is. And finally, display, which is almost exactly the same as the stack just before. For the display part, we also need to know where the head starts. We need to complete these 3 functions. Let us start with Enqueue. Create the parameters for Enqueue first. We must note the head of the queue and what data we want to add. The node to add and its data, node data. Similarly, create a new node first, representing the node we want to add. Create a node. As for the queue, it will be a little more complicated to add, as we are adding from the end. Therefore, we have to find out the position for the end of the entire queue first. In order to add the new node to the end, we need to create an additional current. To help us find out where the end is, current will start with the head of the queue. To look through one by one while going towards the end until it finds the end. As for new node, its data will be the node data in our parameters, where its next will connect to null. Because we are adding the new node to the end, therefore its next will be null. What's next? We will also check whether our head is null or not first. If so, we will make head the new node. That way, we can return where the new head of our new top is directly. If not, we will use current to find out where our end is. Here, we will use whether the next of current is null to make the judgment. We cannot write whether current is null or not directly. Otherwise, we will not find the real end if you write current is null. We will start with the 1, 2, 3, 4, 5 part here. 1 is not null, search behind. 2 is not null, search behind. 3 is not null, search behind. 4 is not null, search behind. 5 is not null, search behind. And our current will end up running to a completely empty space. Instead of stopping at 5, it must be noted that next has to be added instead of just having current. This is incorrect. With the addition of next, we will discover at 5 that the next of 5 is null. So our current will stop here at 5. Before the end is found, we will let it keep searching behind until the end is found. Now that we know that current is the end, therefore, its next will be the new node we want to add. Then we just need to return our head. This is our Enqueue. Next, let us look at DQ. For DQ, you only need to know where the head of the queue is. The part of DQ is simpler. It is almost exactly the same as our pop. You only need to check whether the head is null and that nothing can be DQ'd. There is nothing to DQ. If it is completely empty, just return null. If it is not empty, similar to pop before, we will create a temp node first to store our head. DQ is very similar to pop. We will be deleting the frontmost data. Then make head become its next. We use temp node for storage. For instance, we have 1, 2, 3, 4 now. We want to remove 1. But if we write head equals head next directly, then head will stop here, and we will be unable to find 1. Therefore, we use temp node first to store 1 and make head become 2. Then delete temp node. This way, we can delete 1, and 2 will become the head now. Finally, return head to complete. The last one is display. For the output part, it is almost exactly the same as our stack. We will create a node. Before the node is null, we will display its data. See out node data. And then let node become its next. Keep running and outputting until our node becomes null. Then we can output a small reminder telling the user that you're empty. We can also go to the next row. This way it will be clearer. This is our output. Everyone can take a look. Those who have not completed it can stop here and write it. After completing, let us go back to the main program code region to check whether there are mistakes with the Enqueue, DQ, and output written by us. First, create a head for Queue. It is null at first. Then let us Enqueue and DQ some things. Enqueue a 20. Then Enqueue a 30. Then try DQ. We can also display a reminder. Finally, display our queue. Let's try executing it. We can see that it will display 30 because we added 20 and then 30. Then deleted the 20 at the head. Therefore, only 30 will be left. If it isn't clear enough for you, we can display each one. You will discover that 20 came in first, then 30 came in. Finally, 20 was deleted, leaving only 30 in our queue. This is the writing method for queue. Those who have not finished should catch up. Queue applications. Let us look at the queue practices for stack and queue. Use the data structure of queue. Place the 4 elements of 1, 3, 5, 7 in order. Remove 2 of the elements. Then add 3 elements of 10, 15, 16. Then remove 1 element. And finally, add 20. What is the order of the elements from the front to the end? Please write the program code to implement this example. It is the same here as the program code is the same as the program code practiced in the lesson. Therefore, I will run through it quickly. If anyone needs to listen to the explanation, you can go back to listen to the explanation in the lesson practice. First, create a structure. The node structure. Then declare the 3 functions we need. One data is required for Enqueue, but for DQ, we only need to know who its head is. Finally, it is the part with the display. Similarly, we need to know who its head is. Then we will write these three functions. If you forget how to write these, you can look at my demonstration now, or go back to the lesson explanation. You can also try it out on your own, how to write it. It is more complicated with Enqueue because we will need to find out the end. When we are adding, Q is added at the end. You can check whether the entire queue is empty when you add. If so, we can know that the front end will become the new node. Then return the front end. If not, we will find out who the end is. Why do we make the judgment based on whether current next is empty? You can think about it or check out the video before. This is our Enqueue part. Then we will also write the DQ. The DQ part is much simpler. Similarly, we will first check whether this queue is empty. If so, there's nothing need to be deleted. If not, we will then carry out DQ. If you forget why we need temp node, you can go back to the lesson explanation. Finally, display. For display, all data will be output. After outputting everything, a reminder can be displayed to tell you that everything has been output. Then the three functions will be completed. At last, let us take a look at the main program code region. We need to do something. First of all, let us create the head. it is empty at first. Then we need to carry out some Enqueue and dequeue actions. So let us make a duplication. The total will be, we will enqueue 8 times in total. 4, 5, 6, 7, 8. Starting with 1, 3, 5, 7. Then carry out dequeue. After 2 dequeues, enqueue 10, 15, 16. Then 1 more dequeue. Finally, enqueue 20. Then the display. Okay, let's try executing this. The end result is 7, 10, 15, 16, 20. We can check it manually, starting with 1, 3, 5, 7. Then we will delete 2 things. Dequeue means deleting things in the front. Therefore, 1 and 3 have been deleted, followed by 10, 15, 16. Then delete 1, hence 5 has been deleted. The last one is 20. Therefore, the outcome we have is 7, 10, 15, 16, 20. This is our queue. Everyone can practice a bit and go back to the lesson explanation if you are unclear about anything.